Okay, so this is a little bit of a different video for me today. What I'm basically doing here is trying to help a few people with, says write each as a decimal using repeating decimals when necessary. I'm going to do a few of these problems. I'm going to kind of explain what we're trying to do here. And this is obviously going to be done without a calculator, so I just want to keep that in mind for everyone that is out there. So when we're working on problems like this, I think a lot of times people have a hard time switching fractions to decimals for many various different reasons. So let's talk about it. When we have 6 and 2/5. Now, obviously, my first thing is going to be a 6. Whatever this number is, always will go out front every single time. The 2/5 is what mostly throws a lot of people off. So when you're looking at 2/5, that's kind of hard to just immediately be able to throw in there as a fraction or as a decimal. So the question isn't necessarily, well, what is going to go here? And so I'm going to show you a couple tricks here. Basically, the first trick I'm going to show is if you can get in the bottom a 10, change this 5 into a 10, a 100, or a 1000, then you're pretty gold at that point. And 5 is actually really easy. All I have to do here is take and multiply the top and bottom by 2. Because remember, any fraction can be multiplied by 1, because 2 divided by 2 is just 1. I'm not changing its value at all. And so if I do that, this will become 4/10. Now that's great, because when I have a base 10, then that just becomes my decimal at that point. So this is 6.4. Easy problem for the most part. Not very hard. You just got to think about it just a little bit, and that's pretty much all for this one. Okay, so let's look at this one. So this one is going to be quite a bit more difficult, and I'll explain why. Basically, if I look at this 33 down here, there's no instance where this will ever become 100 or 1,000 or anything because it's a 33. It's got a lot of threes in it, and you can multiply that as much as you like. You're never going to get anything. So it's up here, it says, hey, use repeating decimals when necessary. Now, let's just think about this as if we get really close. If I take and I multiply both top and bottom here by 3, right? 16 times 3, let's see, we got 18, so 48 out of 99. Now, if we look at this is actually really close. 48 out of 99 is really close to hundreds, but we're a little bit off. Now, if I don't have a calculator, this is actually probably where I stop and I don't have to use repeating decimals at all. I would just put 0.48 because that's actually going to be really close to actual. It won't be exactly on actual, but it will be really, really close to actual. And that's kind of what you want to do in a situation like this. If you don't have a calculator, getting close to actual, and if this is a multiple choice question, right, you're going to be pretty dang close to actual at this point. It's not even a hard thing to really think about. But if you do have a calculator, and also this is another thing to think about when you're doing this, this is interesting because we're just one off. And if we extend this like 1 and 1 and 1, right? So we're going to keep this going because we're going to have basically a bunch of leftovers, right? Because we want this divided by 100 instead, right? And so if this was 48 divided by 100, well, technically I still have one more. But was that one, is it over 100 or is it over 99? Well, it's over 99. So what you're actually going to be seeing here is you're going to see 0.48, and then this will actually just continuously repeat. 48, 48, 48, 48 forever. So you can put 0.48 repeating. So if you get it really close to 100, like in this case 99, the odds that it becomes just this top number repeating is actually really quite high. You see it happen all the time, mainly because you're so close to it actually, that whenever you start looking at the smallest details of it, you're just going to see that repeating. And anyway, hope that one helps. Let's go ahead and let's check out the next one. Okay, so let's check out this one, right? Each as a decimal, use repeating decimals and with necessary. This is a very similar as our first one, except this time we got a 25 down below. I will not be able to change that in tenths because 7 can't be divided. And if it could, it would just make me a long decimal anyway. It's going to basically be like making it more difficult. But making it into a hundredth is quite easy. So what we're going to do here is going to multiply both top and bottom by 4 in this case. So 7 times 4 is 28 out of 100. And that 28 is my decimal, so I got 0.28. Easy, simple problem here. Here we have number 4, so we got 9/40ths. 9/40ths is interesting. I can't change a 40th into 100. It just cannot happen. Because if I multiply by 2, you got 80, and you're just going to have problems. So the question is, if I can't change it to 100, can I change it to 1,000? Now, there's a couple ways to think about this. If I'm going to change it to 1,000, is 1,000 divisible by 40? Because if 1,000 divisible by 40, then I can multiply it and get 1,000 base here. So let's go and let's look at this. We got 3 zeros here. We already talked about that. That's 80, so we're going to subtract 80. And this will become 200, and that is a beautiful thing right there, because 200 is, and 400 goes into 200 quite easily. So the question is how many times? Well, it should be 5 times if I believe. 40 times 5. Yeah, that's gonna be it. So 25 times, you're gonna subtract the 200 and you're gonna get no remainder. So if it's going to be 25 to get 1,000 base, all we have to do now is take 9/40ths. Multiply both top and bottom by 25. We already know what 40 times 25. Remember, we're not changing it because we're just multiplying it by 1. We know that that is 1,000. Oh, man, it's hard to draw with a mouse. Sometimes I should get a pen. So 9 times 25. This is going to become a little bit more tricky, so let's go ahead and write this down. Whoops. 25 times 9. 9 times 5 is 45. 9 times 2 is 18, so 8 plus 4, well, let's not put this up yet. It will be 18, so we got 8 plus 4. That becomes 12, so I got 225. This right here is the number that I'm looking for. So I got 0.225. That was 1,000 base, so 3 decimals. Worked out pretty well. Honestly, easier than having to basically guess the last one, but I feel like this is better. And if you ever get one like the last one where you're definitely going to have to be using repeat decimals, it's almost better just grab a calculator at that point. But this one wasn't too hard, and I would think that if I was making a test, I would have made the last one have a calculator portion of the test and a non-calculator portion. This would definitely be a non-calculator portion. So, and I want to say this is more of a 8th grade level. I don't know if you'd see something this. I would say problem number 1 would let's see, 1 and I think 3 would definitely be more of a 7th grade level. But this one would definitely become 8th grade. Mainly because of just the fact that you're dealing with thousands. Let's see, hundreds, thousands, 10,000s, sorry. No, wait, I got that wrong. Thousands is correct. It's been too long. Tens, hundreds, thousands. So when you start getting to thousands, I think that's more of a 8th grade. Let's do one more, and then I think we'll call it there. Okay, so this one's really easy. Matter of fact, why don't you guys try to do it yourselves? Maybe pause the video, give it a shot for yourselves. It has a couple different parts in it, but honestly, incredibly easy. So hopefully you took time to do it, but if you didn't, this is just going to be 2.1. You already have a tens base, so that's not an issue. Don't forget the 2 has to go out front in the ones place. This has to be in the tenths place because we are dividing by 10. That's why it's called tenths, is because it is literally being divided by 10. So there we go, 2.1. You're finished with this problem, and we're done with the 5 problems that I wanted to go over. So hopefully you enjoyed this, and I'll talk to you later. Bye.